Hello everyone, this is another video. This is the second lecture in the Neet Pyqs. Okay, and here I'll be doing more questions from waves. Okay, the second video in waves, right? So last time we did, I think, 9 or 10 questions. I think, okay, 9 questions. Okay, so this will be question number 10 in the waves. Okay, the question number 10. All right. So a tuning fork, right? Your tuning fork is used to produce The tuning fork is used to produce resonance in a glass tube. Resonance in a glass tube. Okay. The length of the air column. The length of the air column in this tube. Length of the air column in this tube can be adjusted. Can be adjusted by a variable piston. By a variable. By a variable piston. Okay. At room temperature of. At room temperature of 20 degree 27 degrees Celsius, two successive resonances are produced at 20 centimeter and 73 centimeter of the column length. The column length. If the frequency of the tuning fork, if the frequency of the tuning fork is 320 hertz, frequency of the tuning fork is 320 hertz. The velocity of the sound, the velocity of sound in air, velocity of sound in air at 27 degrees Celsius is. Tuning fork is used to produce resonance in a glass tube. The length of the air column in this tube can be adjusted by variable piston. At room temperature of 27 degrees Celsius, two successive resonances are produced at 20 centimeter and 73 centimeter of the column length. The frequency of the tuning fork is 320 Hz. The velocity of sound in air at 27 degrees Celsius is. Okay, try. You have 1 minute to solve this question. Okay. So velocity of let me solve it. Velocity of sound in air at 27 degrees Celsius is asked, right? Velocity of sound in air at 27 degrees Celsius. What is given? Room temperature 27 degrees Celsius. Two successive resonances are produced at 20 centimeter and 73 centimeter of the column length. Okay. So L2, this is L1 20 centimeter, this is L2 73 centimeter. So velocity of sound in air So write in velocity of, easy question, velocity of sound in air at 27 degrees Celsius is how much? Formula will be velocity v is equal to, yeah, 2 nu L2 minus L1, okay, or 2f L2 minus L1. This is the formula. This is velocity v, this is nu, this is frequency, okay, frequency of tuning fork. Let me write it here now. Nu is frequency of tuning fork, okay, and L1 and L2 are successive column lengths, okay, column lengths. So the velocity is equal to what? 2 nu. What is the frequency given? Frequency is 320 for the tuning fork, right? So 320. So 2 into 320 into 73 minus 20, right? Yeah. And this is in centimeters, right? L length is in centimeters, so we have to convert in meter. 10 to the minus 2. Yeah. So this will be 640. This is our 53. 10 to the minus 2. So this becomes 339.2 millimeter per second. Okay, that will be answer. So answer will be 339. Sorry, I forgot to write the options. So answer will be 339 meter per second. This is the sound velocity of sound at room temperature 27 degree Celsius. Okay. Yeah. This came in Neet 2018. Okay. Neet 2018. Okay. Next question. Question number 11. The fundamental frequency. The fundamental frequency in an open organ pipe. In an open organ pipe is equal to the third is equal to the third harmonic of a closed organ pipe. A closed organ pipe. If the length of the closed organ pipe, the length of the closed organ pipe is 20 centimeter. Okay. The length of the open organ pipe is the length of the open organ pipe is, okay. Options are 13.2 centimeter, 8 centimeter, 12.5 centimeter, 16 centimeter. This question came in Neet 2018. Okay. Fundamental frequency in an open organ pipe is equal to third harmonic of a closed organ pipe. The length of the closed organ pipe is 20 centimeter. Length of the open organ pipe is, right. You have 1 minute. Okay. So for closed organ pipe, for closed organ pipe, third harmonic will be how much? Third harmonic is 3b by 4l. Okay. And for open organ pipe, fundamental frequency is how much? Fundamental frequency is v by 2l. Right. So what is the question? Fundamental frequency in open organ pipe is equal to harmonic of a closed organ pipe. So just equate them. So 3b by 4l. Okay. 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 Just one thing. This is we can write here closed. This is open. Okay. Yeah. 3 by 4l closed is equal to v by 2l open. Yeah. All right. So v cancelled out. This is 2 cancelled out. What is the question? Uh, Length of the closed organ pipe is 20 centimeter. Okay, this is 20. So L naught is asked. So 3 by 2 into 20, 20 is equal to 1 by L naught, right? 3 by 40 is equal to 1 by L naught. So L naught is equal to 40 by 3 centimeter. That is 13.33 centimeter. Okay. So the option will be option A will be the correct answer. 13 by 3 almost equal to 13 by 3. Yeah. Again, easy question. See waves, okay, like easy questions are coming from waves. If you have seen like last lecture and this lecture, okay. So you should make sure that you do it. Okay, do these questions. Question number 12. The two nearest harmonics of a tube closed at one end and open at other end are 220 hertz and 260 hertz. Okay. What is the fundamental frequency of the system? Fundamental What is the fundamental frequency of the system? Fundamental frequency of the system. So option A 20 hertz, option B 30 hertz, option C 40 hertz, and option D 10 hertz. This question came in 2017 Neet 2017. So all the previous questions I'm doing. Okay, hope you practice them again and again. It will be very helpful. And you try to do faster. Okay, you have 30 seconds to solve this question. Very easy question. 30 seconds. Must maximum 30 seconds. Okay. So nearest harmonics of an organ pipe closed at one end is what? Differs by twice of its fundamental frequency. This is a very important concept. That's why I wrote it. Twice of its fundamental frequency. Right. So, like the difference will be twice of the fundamental frequency. So difference is how much? 260 minus 220. Right. A bit twice of the fundamental frequency. Right. It's 260 to 20. So this is twice. So if I calculate it, 40 is equal to 2 nu naught. So nu naught will be 20. Very simple again. Just small tricks to understand these questions. Okay. Next question is a Doppler effect question, which comes regularly in NEET exams. Okay. Question number 13. Okay. Question number 13. Two cars moving in opposite directions. Moving in opposite directions. Approach each other. Approach each other with speed. With speed of 22 meter per second and 16.5 meter per second respectively. Okay. The driver of the first car, the driver of the first car blows a horn, blows a horn of frequency 400 hertz. Okay. The frequency heard by the driver of the second car is okay. So velocity of sound is given. Velocity of sound is 340 meter per second. It's given in NEET 2017. Okay. So option A 361 hertz. Option B 411 hertz. Option C 448 hertz. And option D 350 hertz. Alright. Two cars moving in opposite directions approach each other with speed 22 meter per second and 16.5 meter per second respectively. The driver of the first car blows a horn of frequency this much 400 hertz. The frequency heard by the driver of the second car is how much? You have 1 minute to solve this question. You can see I'm doing questions year wise. So please try all these questions. You can see questions are coming on a regular basis. Okay, this is a Doppler effect question. What is the formula for Doppler effect? The formula will like frequency formula where at nu bar is equal to original frequency whole into what, velocity of sound v plus velocity of observer divided by v minus velocity of source, right? Yeah. So here, so everything is there given in the question, right? So nu bar is equal to original frequency is how much? What is the original frequency? 400, right? 400. Velocity of sound. V is velocity of sound. Okay. V is velocity of sound. V naught is observer and Vs is source, right? So V is velocity of sound, which is your 340 given in the question. V observer. V observer is what? Approach each other with speed this and this. So first car is the source, right? First car is the source. Second one is the observer. So observer is 16.5, right? So 340 plus 16.5 divided by 340 minus what is the source velocity, 22. So 400 into 356.5 divided by 318. Okay, you solve this, you will get the answer. And the answer will be 448. Option C. 448 hertz will be the answer. Okay. Next question number 14. A siren emitting a sound of frequency emitting a sound of frequency 800 hertz, okay, moves away from moves away from an observer towards a cliff towards a cliff at a speed of 15 meter per second. Okay, then the frequency of sound that the observer hears in the echo reflected from the cliff from the cliff is what? Okay, again velocity of sound is given as 3. Velocity of sound is 330 meter per second. Okay, this question came in Neet 2016 phase 1. Anyway, options are 838 hertz, 885 hertz, 765 hertz. Option D, 800 hertz. Try to solve it. Again, Doppler effect question. Okay, so let's solve it. Frequency of the sound emitted by siren is how much? Siren is the how much? 800 hertz, right? So this is the original frequency 800 hertz, nu naught. Yeah. So speed of source. Siren is moving at a speed of a 15 meter per second. So, so this is VA. V is 15 meter per second. Right. Yeah. The speed of sound in air V is 330 meter per second. Right. So the apparent frequency of sound by the cliff will be the frequency heard by the observer. Right. Yeah. So you can write your apparent frequency of sound at the cliff. Sound at the cliff is equal to frequency heard by observer. Observer is equal to nu. Okay. So Doppler's effect of sound, if we use, that will be nu is equal to V by V minus Vs. Okay, mu 0. So that is 330 by 330 minus 15. Yeah, and into 800. All right. So that will be giving me 838 hertz. That is the answer. This one will be the last question in this wave chapter because we have done enough of waves. Because, I think you'll be if you solve all these 15 questions, you'll get an idea that what kind of question are coming from waves. Okay, no need to like do more. An air column closed at one end, you can see similar type, okay, and open at the other end, and open at the other. Okay, resonates resonates with a tuning fork. Resonates with a tuning fork when the smallest length of the column when the smallest length of the column the smallest length of the column is 50 centimeter. Okay. The larger length the next larger length of the column resonating with the same tuning fork, resonating with the same tuning fork is fork is. Okay. So options. This is Neet 2016 again. Option A, 150 centimeter. Option B, 200 centimeter. Option C, 66.7 centimeter. Option D, 100 centimeter. Right. So you have 1 minute. Try the question. Okay. So solve this question. Very easy question again. So first harmonic is observed lambda by 4. Right. Lambda is given as how much? 50. Right. Which is given as 50. Okay. So third harmonic obtained. Third harmonic would be 150 centimeter. Right. Okay. Yeah. So that will be the answer. Right. So yeah. So this would be your PYQs from waves. Okay. Let me know in the comments what topic you want next, so that I can solve those topics also. Right. Yeah. All right. Okay. Thank you very much. Yeah.